Oh, I see what I did. I did the example 4 problem. And y'all see where I did? I got on the other page. Yeah. So this is just example 4, part C. Here's the checkpoint for part C. All right. Well, it's not the same functions as example 4. So it's my functions. This is an extra example. Just put a star behind it. Say extra over and be above. We don't write that. All right. Yeah. So we're going to do the shortcut. F composed G is 10x squared minus 10x plus 1. I don't know what I said, but did I write it right? 10x squared minus 5x plus 1. And then, since that's the F composed G function, then I can just take that negative 1 and put it in for x for it. So I've got 10 plus 5 plus 1, which is 16. All right.
Has anybody ever watched one of these videos on here and heard me talking about them?
Checkpoint 5 is for determining the domain for composite functions. So this is, we got So first of all, they want me to find F composed G of X, and then on part B, they want me to find the domain. Because remember, this one's kind of interesting when it's a composite function. And this one's even more interesting because they're fractions, right? With variables in the denominator, so I am going to have some things excluded. So first of all, F composed G is I'm going to take the F function. Everybody see I just rewrote the F function. And where the X was, I'm going to put in the G function. Now that is a complex fraction. And there are no books that leave answers in complex fraction form. So to be able to simplify this and put it so that it's just a fraction, I've got to get a common denominator on the bottom. So what is that common denominator going to have to be? It has to be x. And so for the 2, which is 2 over 1, I'm going to have to put 2x over x for it to be able to be added. So this becomes 4 over 1 plus 2x over x. Okay, it's better now because it's just, instead of having 3 terms, I've now got 2. Even though one of them's kind of an ugly looking term. And now the way complex fractions work is once you get the denominator, so it's just one fraction, you just bring it to the top and multiply. So this becomes 4 over 1 times x over 1 plus 2x. So you just get 4x over 1 plus 2x. Okay? That's F composed G of x in the form that it's going to be in the back of the book when you check your answers or on a multiple choice test. Okay? Shira, I'm noticing that you're checking up on me. Now, let's talk about this domain. Remember, I have two conditions for my domain. First of all, the x value has to be something that's defined for the g function, right? So that's, I'm putting the x's in g first. Take the x's and put them in g. So what x's can I not use in the g function? It says 1 over x. This is not a hard thing. What makes the x 0? 0, right? So I cannot use 0. So in my domain, I already know that part of my domain is going to have that I can't have 0 in there. Okay? Now, I also need to know when is g of x going to be the number that gives me a 0 in the denominator of f of x. Okay, everybody hear what I just said? I need to know when g of x is going to give me a number that gives me a 0 for f of x. So x plus 2 can't be 0, right? Y'all following what I'm doing here? I just took the other denominator. Yes? And so x is negative 2 there. But it's not that x can be negative 2, it's that g of x can't be negative 2 on that one. Everybody hear what I just did? So g of x is 1 over x, so it's 1 over x that cannot be equal to negative 2. Everybody understand? On the first one, on the g of x, you can just set the denominator equal to 0. On the second one, you set the denominator equal to 0, but then instead of leaving it x, you've got to put that whole function that g of x is equal to and then solve it again. There's going to be 2 steps to this part. So x cannot be equal to a negative 1/2, right? Because I can reciprocate both sides. Y'all remember that? Okay? So the two things that the domain cannot contain is 0 and a negative 1/2. Go ahead. Go right ahead. We did not get it wrong. I did the wrong problem. It's not. What? Some of you have before. Okay, I'm going to remember that when I'm grading y'all's papers next, and I give somebody partial credit for at least having done the wrong problem that they put down on the quiz correctly.
Okay, I've done that before.
Exactly. He's just saying he's checking, and that's cool. It's nice to have somebody check it. Well, didn't Anthony make me do the right one, though? So there's some penalty involved in not doing the right problem. Okay. So anyway, any questions about how to do this domain thing? You take whatever's on the inside, you just figure out what gives you something bad there. Set it, if it's a fraction, set the denominator equal to 0. If it's a square root, then you set it greater than or equal to 0. But then you got to do the same thing if there's a problem with the f of x function. Now, if f of x had been x squared plus 3 minus 5x to the third, no, I wouldn't have had to do anything, because is there anything that I'm going to put into a polynomial function that gives me a bad number back for a domain? No. So you don't always have to worry about both. The only reason I had to worry about both on this one is why? They both had the x in the denominator. Okay? Does everybody hear what I just said? The only time you have to worry about doing these double exclusions like this is when f of x and g of x both have things that have to be excluded. That doesn't happen very often. Okay? Any questions? All right. So what are the only times that you have to worry about excluding something? Well, when there's a variable in the denominator of a fraction, or if there's what? An even root. and the variables underneath the even root. Okay? All right, there's one last thing. The objective 5 is on decomposing functions. Has decomposition. Decomposing functions just means I'm working backwards. I'm thinking about what composition could I have had that would give me this result. So if you have something, checkpoint 6, tells me that I have that h of x is equal to the square root of x squared plus 5. Now let me tell you now that there are lots of right answers here. Okay? I'm going to give you the simple way to do this. If you'll notice, I've got the square root of something, right? So if I had let one function be the square root of x, and what I replaced x with was x squared plus 5, so if I have f of x is the square root of x, and g of x is x squared plus 5, then f composed g of x would be equal to h of x. Do you get that? Because I took the g of x, and I stuck it in for the x on the f of x, and that's what gave me h of x. So just take the jump kind of underneath. Make that all your g of x, and let your f of x be. Just replace all that stuff that you just pulled out with just the x. There are lots of right answers here, so there's lots of ways to do stuff. If you had that h of x was equal to x squared plus 4 to the third power. Here's my example. Okay? Then this is how I think about it. I'm going to let g of x be the stuff inside the parentheses. And then f of x is going to be where I pulled all that stuff out. It's going to be turned into just an x. And then I'm going to write the rest of the problem down. Okay? Just the easy way to do it. There's more than one way, and some people are going to come up with some different things, and that's cool. There's lots of right answers here. But that's just the easy way to do it, just to pull everything kind of out. If you can find like this place here. Just remember that if you've got another x anywhere else, then you're going to be replacing it with that same thing too. So you kind of got to be careful if that appears in more than one place. Okay? All right. That's all that's in this section.